Logan Woodward. Logan's from Roanoke, near Peoria. So Logan is in the last year of his PhD. The last year. 20 years of schooling, if you count high school and all the college this kid's had. Takes 21 years at a minimum to get a PhD. He's in the last year. He's going to be looking for a job, by the way, in case any of you sponsors know of any. He's going to talk a little bit of a small snippet of his PhD research, focusing on biologicals. A lot of those go in-furrow. He's going to tell you what you can add along with that in-furrow starter. So, take it away, Logan.
Thank you for that great introduction, Dr. Velo. But yeah, as Dr. Velo mentioned, I'm going to be talking a little bit about trying to maximize your yield per gallon on your starter fertilizer applications. And so now I know with the way gas prices have been, a lot of us are thinking about maximizing your miles per gallon in your vehicle. But I'm a corn yield guy, so I'm trying to go and try to look at how we can better increase our starter applications. And so when we first want to start and talk about why do we think about starter fertilizer. And I really like starter because there are a lot of benefits that we can have with this type of system. And so first off, we can provide early season nutrition for that young seedling. So before that the root system can start to develop and it can't necessarily get the nutrients that it might need at a young stage, this starter is able to provide nutrition for that young seedling. And also, as we're going towards earlier planting windows, sometimes our soils here in Illinois are going to be a little bit cooler. And so some of that organic mineralization of nitrogen, phosphorus, and sulfur might not necessarily be there for the crop. So any way that we can provide some more nutrition that they might need can be a great benefit. And I know a lot of you guys may be thinking, well, I used to have starter on my planter, but I kind of went away from it. And so how can this be beneficial to me if I don't have a starter system? But there are a lot of different opportunities with starter fertilizer companies as well as these biological companies to provide at least a little bit of an investment to put a new kit on your planter. And so thinking about kits on our planter, over here you can see our starter and our planter, but I want to show a little bit of pictures of what it looks like. So here's our research planter, and we have a Surefire company in-furrow system, and it does very well for us. And we actually even have 3 tanks mounted on our planter. So we can look at 3 different products all in the same pass, and we can look at 2 different rates as well, all in the same planter pass. And this is ultimately what we're looking at. We're trying to place that fertilizer right where the seed is going to be. We're trying to look for that roots, trying to provide that nutrition and make sure that we're going to be able to help increase yields in the long run. And we've seen this type of response fairly consistently with our starter. We have UTC or untreated control compared to APP or ammonium polyphosphate starter. And when I look at that, I think, well, shoot, man, that's going to be at least 15, 20 bushel yield benefit. But that the relation is that over the last 3 years or so, at about 20 different trials looking at ammonium polyphosphate, we only have an average about 5 bushels per acre increase in corn grain yields. And so I'm a little bit greedy, so I'm trying to find new ways that we can better improve our starter applications. And so I kind of pose this question of how can we maximize nutrient availability and obtain the greatest yield per gallon on our starter fertilizer applications. And one of those options I think can be these biological products. And I talk about biological products, but there's so many different types out there. And the question is, what are these biologicals? And I put a big question mark on that because we've been working with these for the past handful of years, and I have noticed one common occurrence with all the different biological products that we've worked with. And what that is the worse they smell, the better they work. And I tell you what, some of these smell pretty dang bad. And so based on work with myself and Dr. Sybil, we've kind of put together this subcategories of all these different biological products. This isn't an exhausting list. This is just a handful of some of the most common biologicals that people are using right now. And the first one we have is those nitrogen-fixing bacteria. And we think of these as trying to increase the available plant nitrogen availability. And it's doing that basically from fixing air from our atmosphere. And so when I think about nitrogen management on corn, there's a little bit of an issue because we're limited to only 2 different pools of available N for corn to accumulate. And the first one is the fertilizer that we're applying to our soils, and the other one is the soil itself. So all that mineralization from soil organic matter. However, we have this third pool, our atmosphere, which is made of almost 80% nitrogen. But we can't use it, the plants can't use it in that form unless we look at applying these types of bacteria that can fix in. And this is not necessarily a new technology because all of us are aware of the symbiosis with legume crops and Bradyrhizobium to fix in those nodules right where the roots need it. But I'm from Illinois, where corn is king, so we're trying to bring this type of technology into our corn management systems. So when we think about how nitrogen-fixing bacteria can be beneficial, when we have a lot of field spatial variability, and with all the different rainfall events, having a lot of weather-induced nitrogen losses. So any way we can basically try to get that third pool of nitrogen and make more it available across all of our acres can be extremely beneficial. And so these bacteria are living on the root system when we're applying them in furrow, and it's basically a symbiosis with the roots to get sugars from the roots, and then the bacteria are providing nitrogen for the crop. And when we think about what Dr. Bilo mentioned earlier, as we're striving towards higher yields, we're going to have to ultimately keep increasing our planting populations. And unfortunately with that, we're going to have a smaller individual root system on every crop. So when we think about how we're going to get those immobile nutrients to those smaller roots, we have to think of ways that we can try to increase our root surface areas. And one way we can do that is with mycorrhizal fungi. So we call these an extension of our root systems, and I have some photographic evidence to prove this. So here we have just your regular roots at the tip, but then when we have these white hyphae, mycorrhizal hyphae, these are be able to create a community in the soil and basically reach out into areas that normal corn roots will not be able to get. And this helps with phosphorus uptake, water accumulation, and many other nutrients as well. And so if we're trying to increase this root surface area, the issue is with phosphorus management, a lot of that is unavailable for the crop. So this is a published study from Purdue University, and on similar soil types to what we have here, we have around 1,200 pounds of total phosphorus in our soils. That's great, right? I mean, that's more than what we need for plant accumulation. But the issue is only up to 0.1 pounds of that is available at one point in time. So we're trying to find new ways to make some of that unavailable phosphorus in the plant available form for uptake. And so of that total unavailable phosphorus, we have some that's in either organic matter, or we have some that is bound to mineral nutrition, bound to mineral forms, and also in some of our parent material as well. And so one way that we can try to make some of that phosphorus available is with phosphorus solubilizing bacteria. And one way, the way we think about phosphorus in our soils that are in the mineral form, we have phosphorus that is bound to those heavy metal cations. So depending on if you're on more acidic or basic soils, it could be bound with aluminum, iron, calcium, and zinc, and many other cations as well. And that right there is unavailable for plant uptake, unless we apply that phosphorus solubilizing bacteria. Those PSBs are ultimately giving off weak organic acids, and they act as a sort of chelator of sorts. And they break down that bond with the cations with the phosphorus, and they ultimately make that P available. And I said they act as chelating agents, so ultimately they're keeping those cations from binding with the phosphorus in our soils, and as well, they're trying to keep your phosphorus fertility from binding to those cations. So it ultimately can do two things: make the soil, the P that's in the soil available, but also improve your phosphorus efficiency. And so the other fraction of unavailable phosphorus that I talked about is in that organic form. And these enzymes, like phosphatases, can also help make that plant available. And the way that does is here we have, you have your organic matter, and then the phosphorus that is bound to that organic matter. And then when we apply those phosphatase enzymes, they act as sort of a Pac-Man, and they just keep chugging and eating off that organic matter and breaking that down, and ultimately making that phosphorus available for uptake. And then another one we have is those humic and fulvic acids. Those are some complex carbon molecules, And on those carbon structures, they have many different areas that have negatively charged components. So those are similar to some of the phosphorus solubilizing bacteria. So they'll be able to ultimately act as some sort of a chelating agent and make some of that phosphate available, as well as other nutrients. And also, these are, like I said, they're carbon molecules, so they can act as a sort of carbon source for the molecule, for the microbes in the soil. Basically, kind of stimulating some of those microbes to be acting on some more of that phosphorus and other nutrients to make it available for crop uptake. Next ones we have, I'm going to put these two together, the marine extracts and the sugars. These are also carbon compounds. So sugars are more smaller and readily available sugars, and the marine extracts are a little more complex. So those both act as ways to stimulate microbes as well and help develop better root systems. And lastly, we have the plant growth regulators. These are some of the original biological products, and these are ultimately, plant hormones, and they regulate growth. So there's many different types of hormones out there. The main ones are the auxins, cytokinins, and gibberellic acids. So they help either promote root growth or shoot growth or some other sort of growth as well. And so here's all the biological products that we've kind of been looking at mostly. And in the past couple of years, we've been really starting to look at some of these synergies with biologicals and starter fertility. So in last year in 21, we started this first trial where we're looking at untreated control, and then APP starter fertilizer by itself, and then we added a bunch of different biologicals, that being a couple different PGRs, a biopesticide, and mycorrhizal fungi. And so this was planted around early or end of April, so this was somewhat early for us that year, and so we're still having some of that cooler soil temperature, so we expected a decent starter response. And we had a UTC of 270 and plus a 7 bushel benefit with starter fertility. We were pretty happy with that, but when we applied some of these additional biologicals with that, we had some even better yields. So some of these, the one PGR, they're not all the same. Some of these PGRs are a little bit different, but we had an 8 bushel benefit with the one, and we also even had a 6 bushel yield benefit with mycorrhizal fungi. And that biopesticide, some of these biologicals are, Dr. Beal said, they're in question. Some of these are still trying to figure out how efficient these are, and so sometimes we're not having the greatest yield benefit. But all in all, we were pretty happy with some of those results. We had a very similar study in that same year right next to it, and this one we were looking at, again, the untreated control, APP, and then some humic acids, seaweed extracts, fulvics, amino acids, the whole 9 yards. And this one we had a 6 bushel yield benefit with APP, but then when we look at the biologicals, oh boy, we had some pretty good yield benefits with a handful of these types of products. So earlier I was talking about those sugar type compounds, and so we typically like to look at sugars applied in furrow, and because these are acting as a direct energy source for the microbes. And most of the sugars that we looked at were those simple sugars like glucose and fructose. And so we got 2 different sugar compounds. The first one we call it flintose. And when I look at this substance, it looks a little bit of a suspicious substance, if you ask me. And then the other sugar source we had was high fructose corn syrup. So they basically took from some bio processes with corn, and then they made sugar from that, basically that sugar that we all eat and drink. And it turns out Pepsi and Coke aren't really wanting to buy as much of those sugars, so there's a lot of this amount of sugar. And like I mentioned, this is made from corn, and we're applying it on corn. We also call that cornivalism. And so with these products, we also wanted to look at their interactions with starter fertility as well as a phosphorus solubilizing bacteria. So the reason we want to look at this is APP is all in polyphosphates. That currently is in a form that's not available for crop uptake. So we're trying to either provide sugar to increase the activity of inherent soil microbes to break down that polyphosphate into ortho, which is available for uptake. And we're also applying a phosphorus solubilizing bacteria with it to see if that's going to boost some of the inherent soil microbes as well. And then look at the interactions with the PSB and the sugar. And so the UTC, the untreated control, gave us 251 bushels. And we had a similar response with APP to the other 2 studies with a 5 bushel yield benefits. So when we look at the two sugars, the first on the left is Clintos and on the right is the high fructose corn syrup. When we applied those by themselves, we didn't really have much of a benefit compared to the UTC. And we had a similar response with the phosphorus solubilizing bacteria. So we didn't get any benefit in yield when applying just the single biologicals by themselves. But when we applied the phosphorus solubilizing bacteria with the sugar, we had similar or even better yields than the starter fertilizer by itself. So it didn't apply any phosphorus in that furrow at all, and we're still able to get similar yields as APP fertilizer. But now when we look at adding the sugar to the starter fertility, we had 11 or a 12 bushel yield benefit compared to the control. So we're really starting to get some of those synergies where we're increasing the activity of the soil microbes to make some of that polyphosphate available and keep it available for longer. And then lastly, we had the starter with the phosphorus solubilizing bacteria. We had the greatest yield benefit of 13 bushels compared to the control. So some of my key takeaways: starter fertilizer is a viable option to provide early season nutrition. And I really like starter, but sometimes starter isn't necessarily finisher. We need to include something else with it or try to manage that crop to make sure we see that early growth benefit seen in yield. And then even though starter is not finisher, there are still ways that we can maximize our yield per gallon by adding biological products with starter. And then I'm not sure, Dr. Beal, you have any questions?
Yeah, we do have time for a question or two. Anybody got a question? Yes, sir, over here.
Which one of those sugars more closely resembles the root exudates that are naturally occurring in the soil?
Good question.
Yep, so the question was which one, the Clintos or the high fructose corn syrup, more mimics the root exudates that corn roots give off. And to be honest, it's a mixture of both. It's a mixture of both the Clintos and the high fructose corn syrup is what similar what corn roots give off.
Other questions?
Do you have to have an in-furrow or a 2x2 to still work, or you can test that?
Sorry, one more time?
Does it have to be in furrow or could it be 2x2?
Oh, so the question was, can we look at starter with biologicals either applied in furrow, or can we put it off to the side a little bit, 2 inches off, 2x2? And we haven't actually looked at 2x2, but I would imagine we would still have some benefit, maybe not to the extent as in furrow, right where that those roots are going to be, but even 2 inches off, you're still going to have some soil contact and be able to have some of those microbes still colonize the root system.
Last.
Is there an amount per acre of sugar that you would recommend?
So the question was, is there an amount of sugar that we recommend? And I believe we typically applied this around 5 to 10 pounds of total sugar.
4 pounds.
4 pounds of sugar. Sorry.
It's cheap. Other questions? Adam.
You see the same trends across different yield levels.
So the question was, do we see similar trends with these biologicals in different yield levels? And yes, so there's many different types of biologicals, and some of them work better on your harsher acres. But with the phosphorus solubilizing bacteria, we have seen that when you have a lot of unavailable P, a really high soil P test, there is more phosphorus that microbe can go after and make available. So it kind of just depends on where you're at and what type of biological product you're working with.
We got time for another one.
Would you expect the southern Illinois soils to respond better, same?
So the question was, do I think that southern Illinois would be better with these responses? And yes, I do believe it can be better. But I do think that there is benefits depending on no matter where you're at necessarily.